hello again. So now we're talking about Federated Assemblies, which I work with my advisor Ariel, Nimrod, and Ehud, who's here in the audience. Back to this. Talking about citizens' assemblies. So what are citizens' assemblies? What's their goal? It's to involve ordinary people in some democratic decision-making process. And sort of the high-level way how they're frequently implemented is we randomly select a small panel of people from a large population. So everyone sort of has a chance of being on this panel. We bring them together and they deliberate with each other and they make some policy decisions, suggestions, depends what the topic is at hand. And really these are like used all over the place. They're gaining lots of traction. So here's just a list of countries. Ireland had some stuff on constitutional issues where the citizen assemblies really had a big impact. France has some things on climate change. How should we decide how to regulate? Germany had a recent one on like nutrition policy, which I thought was kind of cool. A little different use case. But a list of countries goes on and on. There's some like permanent fixtures. Just really cool applications. Even beyond just like country political things, companies like Meta, like how should we do AI governance? That's spelled wrong. But important things where we want to get real people's opinions on various topics. Right, so let's return to this process, this two-step thing. Today we'll really be focusing on this first one. There's been lots of really cool work on both these aspects. I think a little more on the first step, but today we'll be focusing on this first one. How do we even randomly select people in a good way? And the ideal goals is you have these two competing aspects. You want people to have good chances of being on the panel, like ideally equal, everyone shot. And you want the panel that you select to actually be like representative of the population. You don't want to end up with like a bad draw, and like some people are, the panel does not look like the population we're trying to represent. And so there's really been a lot of beautiful work recently and like really practical work on how to do this well. And this key question they have to answer first is, what does it even mean for a panel to be representative? And the thing that's been done so far is that we frequently set quotas on various features. We decide upfront, what are things that we really need to be fair and representative on? Things like age, like we should have the right distribution of people in various age groups, education level, all kinds of features like this, or even your like prior opinion on the topic at hand. But what they want to highlight is like these are things that have to be set by the assembly organizers. And potential things like, what if we missed some key features? What if there's some other feature that we're not accounting for, and then due to the random draw, they end up unrepresented on the panel. So the way to think about this instead is try to solve a slightly different problem, and hopefully find a way that these different subgroups can form organically and get representation rather than us deciding upfront. We want to think about this is by what we call federated assemblies. So the idea is maybe we have an assembly. I want to think of these like permanent assemblies, a future where we this has already started some places, but we've really bought into the citizen assembly idea. And we have like a permanent like statewide assembly and a bunch of citywide assemblies as well. And the cities have various population sizes. And we can imagine these assemblies working together. Sort of like the city assembly like feed into the state assemblies. We want representation to go both ways, and local people are in the state assembly, they go back to their like local assemblies and ideas can transfer, stuff like this. In a situation like this, it feels very easy to like, what would it mean to be representative? Probably our state assembly should have a number of representatives from each city proportional to their size. This seems extremely reasonable. But of course, the worry is maybe by just doing this, we've missed out on some key subgroup. We just took people from various cities, but we always took people from who look kind of similar, something like that. And we end up with an unrepresented state assembly. So the hope is if we have like trust like this is the if some subgroup feels unrepresented, we get them an opportunity to create their own assembly and join into the state. So what do I mean by this? Like maybe there's a set of teachers that feel like their views are not being out of the state. So what they can do is create their own assembly. Here at teachers, we have our own discussions. We have our randomly selected set of people. and join into the state assembly, and then this forces them to be represented. So kind of a somewhat radical idea, but I think like it leads to some nice ways that we can try to be representative in a model like this. And the idea is that people can sign up for multiple assemblies like this. You can both be in your local city and the teacher assembly, but it forces you also to like distribute some weight and like how much you think to these things matter to you. Right, so we want to proportional to its weight and size. So some potential benefits of this is it allows like more organic forming of recognized subgroups. If someone feels unrepresented, they can create their own thing. It doesn't have to be decided up front. And as I said, you can allocate your weight among these things depending on the things. But it does bring up new questions on how do we even select the assemblies given structures like this. So the idea we're going to have is we're going to have in our setup, we're going to think of a bunch of assemblies working together. They sort of form a DAG of how assemblies feed into each other. And people are signed up for various of these leaf assemblies. And the population that assembly is represented is just the union of all of the leaf assemblies and their descendants. So for example, like the fifth assembly is representing everyone who signed up for either A2 or A3. And our goal now is to randomly select a panel for each assembly simultaneously. An additional requirement that we want that we kind of discussed on the last slide is we really want the panel structure to reflect this inclusion structure in the form of the representative, so that people can kind of go back and forth with ideas. We really want the panel for A5 to be selected from the panels of A2 and A3. So yes, I guess my animations got messed up when I exported to PDF. But so now new representation guarantees make sense. We still have this idea that we want individual representation. So for any specific assembly, we want the probability that anyone in the population is chosen on the panel to be equal for everybody. But we also have this assembly-child relationship that we want to maintain. So for every assembly that is a child of another, they deserve their like weighted proportion of the parent assembly. And ideally, we would have this as an ex post thing, like in every example. The proportion of parent assembly is proportional to the children. We may also want some ex ante guarantees and expectation if these are not integers, we would still want to get the fractional fix correct.
A clarifying question. So the leaf nodes have the same sizes, the assembly sizes?
I think the panel sizes are the same, but their populations could be totally different. Populations are flexible. So just to talk about our results, so if you fix this like tree-like, these region-like structures, these are pretty reasonable. So this is, you think you have like city level assemblies feeding into state levels, feeding into country level. There's a straightforward algorithm that would let us get all of these properties. Sort of the key concept here is if you want to select the parent from two children, you first like round the number of seats that you want to give to each child. So when if we're going to pick 5 people, the blue unity deserve is like 35% or 65%. We'll round to either giving 2 seats to the blue and 3 seats to the green with probably 40%, so 75, and then the other way accordingly. And then we just pick a panel according to this, and this will satisfy all of our probability and ex post guarantees. But trees aren't enough. We really want to be able to handle some other structures on top of this. So in completely general graphs, it is possible to get individual representation and this ex ante child representation. So just the probabilistic guarantees. This maybe sounds easy just by people selecting people completely at random. But I would say this really is a very non-trivial because of the subset constraint. The fact that you have to choose panels such that the child assemblies the child panels are a subset. Sorry, the parent assemblies are a subset of the all the children. There's non-trivial constraint. We kind of have a cute randomized rounding algorithm that is able to achieve this. We can generalize beyond trees. So we have a class of instances. I can't describe too exactly right now, so it takes a little bit to describe them. The idea is that you have an underlying region graph, and then also this is sort of fraught with different subgroups. So in every region, there's an assembly for every region, every subgroup, and these feed into each other in very natural ways. It's sort of like a global region one for all subgroups together, and the subgroups also have a similar region tree structure. So we think of this as like a very reasonable structure, and we are able to get most of the guarantees up to some small approximations, but I will say even adding this extra level of complexity already makes the algorithm much more complex. We have to handle all these cases. It's like a very long, like many randomized rounding steps, like invoking other algorithms. So I just want to wrap up. So we have this new structure, like an alternative way to do set assemblies we call federated assemblies, multiple assemblies interacting with each other. And I think it does really lead to these new natural notions of representation that we might want to set. But there's still a lot of new directions open. We've only done a small amount of work here. So for example, this question of like trying to get ex post child guarantees in visual representation in more general graphs, we really don't have much idea. We have some small impossibilities that like very like simple classes of algorithms can't work. But even like existence results, is it even possible to get all these things simultaneously? It's pretty open. But on top of this, like much more practical questions about this. We really have these permanent assemblies. We probably don't want to be completely randomizing every time we're replacing everybody. You can imagine some sort of rotating structure, people coming in and out, just regular people having a term for a while, and then you can have different guarantees on top of these that might make sense in over time structure. And the real question is like, how do we even get these organic assemblies to form in the first place? How can we have infrastructure set up for this? While people do this, but I think still some exciting new questions in this direction of citizen assemblies. That's all I have for you. Thank you.
You have time for one or two quick questions. That's great.
From a practical point of view, do you think there might be problems with saying like, okay, some citizens are in a panel for their city, but maybe they do not feel capable of like being a representative for like decisions on the whole country level, let's say like that, right?
Yeah, no, that's a fair point. I mean, it's like, can you even like force people to be at all levels of this graph? Yeah, I mean, we haven't thought too much about the practical things. I think just other ways to define notions of representation come from this. But yeah, definitely some practical things you'd have to solve first.
Okay, last question.
When you said in the previous slide, you mentioned that you can show the existence of these properties for general graphs. Is that polytime algorithm or just?
Yeah, it's a cute polytime algorithm. So that's like.